Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice all the entrance exam question papers because all the papers along with the detailed PDF solutions are available there. Also, you must download our app. The link is available in the description box. So students, today I'll be solving JEE Mains 5 April Shift 1 paper. I'll be solving near about 30 questions of mathematics in this particular video. So let's start. Best of luck. Here we go. First question says, let D be the distance of the point of intersection of these two lines from this point. Then what is D square plus 6 equal to? Okay, so here is your first line. This is x plus 6 upon 3, y upon 2, and z plus 1 upon 1. Let's say this is equal to some k. This is, let's say P1. Okay. So P1 point, any point which is lying on this line, this will be generally given by 3k minus 6. And this will be 2k and k minus 1. And any general point P2 on this second line, which is x minus 7 upon 4, y minus 9 upon 3, z minus 4 upon 2, let's say that is equal to some alpha, it will be given by 4 alpha plus 7, 3 alpha plus 9, 2 alpha plus 4. For the point of intersection, these 2 points will be same. So, so technically you have P1 equal to P2. This gives me 3k minus 6 is equal to 4 alpha plus 7. Also, 2k is equal to 3 alpha plus 9. So let's solve for this. You have k is equal to 3 alpha plus 9 upon 2. Right, let's fill in this one. So you have 3 alpha plus 9 upon 2 minus 6, 4 alpha plus 7. So this is the one. And this will be 9 alpha plus 27 minus 12 upon 2 is equal to 4 alpha plus 7, or 9 alpha plus 27 minus 12. This will be 15 is equal to 8 alpha plus 14, or you have alpha is equal to minus 1. I got the value for alpha is equal to minus 1. Let's solve for k. K will be equal to 3 into minus 1 plus 9 upon 2, which will be equal to 3, 6. So this is 3. So I got alpha as minus 1 and k is equal to 3. So that means let's make the 2 points. These were the 2 points. Let's make them. So P1 is, what was it? P1, that was 3k minus 6, 2k, k minus 1. So this point becomes, this is any point, right? This is 9 minus 6, 3, and 6 and 2. So 3, 6, 2, this is the point. Now let's find out what you asked. The distance of this point from this point, 7, 8, 9. So you have to find out the distance between these 2 points. This distance will be given by root of 7 minus 3 square, 8 minus 6 square, 9 minus 2 square, which is equal to 4 square, 16, and 4 and 49. So you have root of 69. This is the answer. This is a D. I hope we had to find out this only. Okay, I had to find out D square plus 6. So this gives me D, this was D, so D square plus 6 will be root 69 square plus 6, which is equal to 75. So this is the answer to the question. We have C option as the correct answer. Hope you're clear with this. Let's move to the next question then. Let the rectangle ABCD of side 2 and 4. So these are the type 2 and 4, 2, 4 and 2. Inscribed in another rectangle PQRS such that the vertices of the rectangle ABCD lie on the sides of PQRS. I have drawn the figure for you. So it says let A and B be the side of the rectangle PQRS when its area is maximum. Okay. Then you have to find out a plus b whole square. All right. So first of all, let's say this is the angle theta. If this is the angle theta, this angle will be 90, 90 degree. So this one is 90 minus theta. This one is again 90 degrees. So this is supposed to be theta only. Similarly, this is also theta and this one is also theta. So these are the angles, right? Now, next thing, PD is equal to, this is 4, right? So wait, you can write down, if I'm using this triangle, triangle APD. So you have cos theta is equal to base upon hypotenuse, right? So this is the right angle triangle. Cos theta is equal to base upon hypotenuse, or what is your base PD, and hypotenuse is AD. So 4 cos theta is equal to PD. Similarly, 4 cos theta you will solve, you will have a, wait, you will solve for PS. This one, PS, the whole one. First of all, let's solve a DS also. DS. It's coming in this triangle, triangle. Let's take in triangle CDS. So you have sine theta is equal to perpendicular upon hypotenuse. So this is ds upon dc. So this is ds upon 2, or ds is equal to 2 sine theta. Now ps is equal to pd plus ds. So this makes it 4 cos theta 2 sine theta, right? And next, similarly, we find out AP will come out to be 4 sine theta, and QA will be 2 cos theta. QP will be given by QA plus AP, or 2 cos theta plus 4 sine theta. So I got the length and the breadth. I got this is your width of the triangle PQRS, and this is the length of the triangle PQRS. So area will be given by length into width. That is your PS into QP. So this is equal to, what was that? 4 cos theta 2 sine theta into 2 cos theta 4 sine theta. Let's take 2 and 2 common from both of them. So 4 will come here, and you will have sine theta plus 2 cos theta, and here will be 2 sine theta plus cos theta. Let's open it up. You will have 4, and this will be 2 sine square theta plus sine theta cos theta plus 2 sine square, 2 sine theta cos theta, 2 into 2, 4. Wait. Okay. So sine theta, wait, yeah, let me check once. 2 sine square theta, sine theta cos theta, 2 into 2, 4 sine theta cos theta, and 2 cos square theta. This and this will give you 2. So 4 into 2 plus 5 sine theta cos theta. This is 8 plus 10 sine 2 theta, right? Because 2 sine theta cos theta, it will give you sine 2 theta. Okay, this is the area. Now, what in the question is, area should be maximum. For the maximum area will be maximum when this will be maximum, obviously, will be maximum when sine 2 theta, and the maximum value sine can have is 1. So this is equal to sine 90. So theta will be equal to 90 upon 2, that is equal to 45 degrees. So maximum area will be there when theta, that the theta angle made is 45 degree. And in that case, the maximum area will be given by 8 plus 10 into sine 2 theta. This is equal to 18. This is the maximum area. Okay. What you had to find out in the question was, okay, A and B. So I got a theta. This was your A length, and we just calculated the PS was equal to 4 cos theta plus 2 sin theta. So what will be your PS? Let's solve it here. So what was your A? A was your PS, which is equal to 4 cos theta, 2 sin theta. This is equal to 4 cos 45 degree, 2 sin 45 degree. And this is this. So 6 upon root 2, or you have 3 root 2. Okay. This is your A, and the B was equal to your QA, which is 2 cos theta, 4 sin theta. 2 into 1 by 2, 4 into 1 by 2. This is the same 6 upon root 2, which is equal to this 3 root 2. And what you have to find out in the question was A plus B whole square. So A plus B whole square will give me 3 root 2 plus 3 root 2 whole square, 6 root 2 whole square, or 36 into 2, 72. This is the answer to the question. Hope you're clear with this. Option A is the right answer. Right? Let's move to the next question, number 3. Question number 3. Let two straight lines drawn from the origin O intersect this line at the points P and Q, such that triangle OPQ is an isosceles triangle and POQ is 90 degree. If L is equal to this, then the greatest integer less than or equal to L is. Fine. So let's see. This is the figure over here. This was your point O, and this is your line 3x. This one is 3x plus 4y is equal to 12. So this is the line, and in the question you are given that angle POQ is 90 degrees. So this angle is equal to 90 degree, and OPQ is isosceles triangle. So that means if this is 90 degree, this angle will be equal to this angle, and both will be equal to 45. And let's say this is A side and this is A side. What will be if OP is equal to A, OQ is equal to A, PQ will be Pythagoras theorem. It will be given by root of A square plus A square, which is equal to this root 2 into A. Okay. Now, let's consider these two lines, OP and PQ. Angle between them, 45, right? Also, you know that angle between that tangent of 45, that is angle between the two lines, is given by modulus of m1 minus m2 upon 1 plus m1 into m2. So here your m1 is the slope of this line. What is the slope of this line? This will be 4y is equal to minus 3x plus 12, and y will be equal to minus 3 by 4x plus 3. So this is the slope minus 3 by 4. M1 is equal to minus 3 by 4. Or let's say this will be tangent of 45 degree. This is equal to 1. So this is minus 3 by 4 minus, okay, minus 3 by 4 minus m2 divided by 1 minus 3 by 4 m2. Or you will have here 1 minus 3 by 4 m2 is equal to 1 minus 3 by 4 m2 is equal to m2 plus, like this is the modulus, so I will write it as m2 plus 3 by 4, or you have m2 minus 3 by 4, m2 is equal to minus this, and you have 1 by 4, m2 is equal to minus 1 by 4. Will be equal to minus 7 by 4. From here you get m2 is equal to 1 by 7. So this is the slope of OP line. I got the slope of OP line as this. Now equation of OP, because it is passing through origin and it is having the slope 1 by this. So equation will be given by y minus 0 is equal to 1 minus 1 by 7 x minus 0, or you have y is equal to 1 by 7x. Now let's find the point of intersection that is P of OP and OQ. OP had the equation y is equal to 1 by 7x, and OQ equation was this. Let's fill in x over here. You will have 3x plus 4 upon 7 into x is equal to 12, or you have a 21x plus 4x is equal to 84, 25x is equal to 84. X will be equal to 84 upon 25, and similarly you will solve, you will get the value of y. Y will be equal to this 84 upon 84 into 1 by 7 upon 25. This will give me 12 upon 25. So this is the point of intersection P. P came out to be the point 85. 4 by 25 and 12 upon this. Correct. Let's find out the length of OP. So from here, OP will be given by, I have the coordinates of O, which is origin, which is 0 and 0. So this will be given as I took it as A. So this is A square. This is equal to 84 upon 25 whole square, 12 upon 25 whole square, which will give you the value of A square as this. 25, 288 upon 25. So you know one thing, that OP is equal to OQ. So that means both are equal to A square. Correct? OP was equal to A square. OQ is also equal to A square. PQ was equal to root 2 into A square. So PQ is equal to root 2 into this. Okay. Let's do the square of it. So this is 1. Okay. This will be given by 6, 7, and 5. So this is the value of, it was 25, right? This is the value of PQ square. And now you have to find out the length of L, which is OP, PQ square, and OQ square. This is A square, and this was your A square, and this is equal to your 2A, sorry, this is 2A square, and this is this. So this makes it total of 4A square, which is 4 into 288 upon 25. So on doing all the calculations, we'll get 46.08 as the answer. And okay, greatest integer less than or equal to. I got the value of L as 46.08. So the greatest integer less than or equal to this number is 46. Option D. C. Option C is the right answer to the question. Hope you got that. Let's move to the next question then. Question number 4, if y is equal to yx is the solution of this differential equation, and y of 0 is equal to 3 by 4. You have to find out y of pi by 8. Let's write down the equation. You have a dy by dx plus 2y is equal to sine 2x. Here, the integrating factor is given by e raised to power integral of 2 into dx, which gives you e raised to power 2x. So now the equation will be y into the integrating factor, which is equal to this, is equal to integral of integrating factor into this function of x dx plus c. This gives me e raised to power 2x into first function into integral of second. So this gives me minus this upon 2 minus integral of derivative of first, which gives me this, into 2 integral of second, which is minus cos x upon 2 dx. This 2 and 2, this will get cancelled, and you will have y into this is equal to e raised to power 2x into cos 2x upon 2 minus minus plus, again the first function into integral of second, integral of e power 2x cos 2x. Again, integrating by parts, this will be equal to minus e power 2x into cos 2x upon 2 plus same thing, first function into integral of second minus integral of derivative of first into integral of second. This 2 and cancel. This, see, this is equal to y into e raised to power 2x itself. So you have y into e power 2x is equal to this cos 2x upon 2 plus this is e 2x into sine 2x upon 2 minus y into this from 1. From 1. Okay, so this is equal to 2y e power 2x is equal to, I'm taking e power 2x upon 2 common. This is sine 2x minus cos 2x. Right, so you have this thing is equal to e raised to power this upon 4, this, right? Here's plus the c constant 2x minus cos 2x plus c. Now in the question you are given y of 0 is equal to 3 by 4. That means when x is equal to 0, y is equal to 3 by 4. So 3 by 4 into e power 0 is equal to e power 0 upon 4 sine 0 cos 0 plus c. This is equal to 3 power 0 is equal to 1 by 4 into minus 1, right? Plus c. So this gives me c is equal to 1. Now what you have to find out is y of pi by 8. Let's solve. Now the equation becomes y into e power 2x is equal to e power 2x upon 4 sine 2x minus cos 2x. See, this will cancel. This will cancel, just cancel it straight away. You have to find out y of pi by 8. That means the value of y when x is equal to pi by 8. So this is 2 into pi by 8 cos 2 into pi by 8. So this is y is equal to 1 by 4 pi by 4 sine minus this. And this is equal to 1 by root 2 minus 1 by root 2. So the answer is 0. There is a correction in the sum. I did a mistake. There was c is equal to 1. So here was supposed to be plus 1 for this c. Now this whole question will change. So now let's start the question from here once again. So here e raised to power 2x upon 4 into e raised to power 2x sine 2x cos 2x plus 1 upon e raised to power 2x. So here y will be equal to 1 by 4 sine 2x cos 2x plus e raised to power minus 2x. Let's find out y of pi by 8, which gives me y is equal to 1 by 4 sine 2 into pi by 8 sine pi by 4 cos pi by 4 e raised to power minus 2 into this. So this is equal to 1 by root 2 minus 1 by root 2 plus this will be e raised to power minus pi by 4. So this is equal to, because this will be 0, y will be equal to this, e raised to power minus pi by 4. So this is the answer to the question. Let's check with the options now. Okay, I don't have here. Anyways, the answer to the question over here is e raised to power minus pi by 4. Hope you're clear with this. Let's move to the next question. Question number 5 for the function fx is equal to sin x plus 3x minus this, where x belongs to 0 to pi by 2. You have to consider these two statements and check which of these is true. You have the fx function as sin x 3x minus 2 pi x squared plus x. Here x belongs to this interval. So for the increasing or decreasing, let's find out the first derivative of x. Sine is having cos plus 3 minus 2 upon pi 2x plus 1. This gives me cos x minus 4x upon pi minus this plus this. As you are given x belongs to this interval, so that means if I say 4x plus pi, this will belong to 0, 2 interval, right? So if this is true, then that means 3 minus 2 pi minus 4x upon pi. This is also greater than 0. And you know, cos x is also positive when x lies in this interval, 0 to pi by 2. In the first quadrant, cos is positive. So that means the first derivative, this is positive, which means that fx is increasing function. Now let's go on for the second derivative. This was sin x, for that cos x. Cos x derivative minus sin x minus 4 pi. Okay. Now this is less than 0 because x belongs to this interval. Same thing, right? This is in the first quadrant. Sin is positive, so this will give you a negative value, and this is also negative value. So this is going to give you a negative value. That means your fx is decreasing function. So both the statements 1 and 2 are true. Option D is the right answer to the question. Hope you're clear with this. Let's move to the next thing. Question number 6. If the system of these three equations have infinitely many solutions, what is the value for lambda power 4 minus mu? So infinitely many solutions these lines have, that means their determinant is equal to 0. Next, write them these three equations in the matrix form. This will be given by 11, 1, lambda, 2, 3, 5, this. So this determinant is equal to 0. So let's solve. This is the minus 39 into 3, which is the minus 117 plus 95 minus 1. This is 39 twos are. This is 78 and minus 40 plus lambda into minus 38 minus 24 is equal to 0. Or here you have minus 11 and this will give me 22 and this will give me 242 minus and this will be plus 118. Yes, and minus 62 lambda is equal to 0, or you have 62 lambda is equal to, let's solve both of them. You have 242 and 11843, no, 421, 124, or lambda is equal to minus 2. Right, so I got the value for lambda. Now, delta 2 will be given by, I'll be taking 11, 1 and minus 5, 11, 1 and minus 5, 2, 3, 3, 8, 19 and mu. This also should be equal to 0. Let's find out the determinant again. You have 11 into 3 mu plus 57 minus 1, 2 mu minus 24 plus 5, no, it's minus 5 into minus 38 minus 24 is equal to 0. This gives me 33 mu plus 6 to 7 to mu 24 plus this is, okay, let's solve this first. This is 2, 6 into 5. This will give me 310. Okay. This is equal to 0. This gives me 33 mu is equal to, no, 33 mu. This is 31 mu. This and this will give me 31 mu is equal to 3627310 24 1 and 6 and 9. So this is the one. Or mu will be equal to, this is the square of 31, I think, right? Let's check. Yes, this is the square of 31. So mu is equal to 31 minus 31. Right. Okay. So the next one you have to find out lambda power 4 minus mu. Your lambda was equal to minus, what was the value of lambda? Was minus 2. And the mu was minus 31. Lambda power 4 minus mu will give me minus 2 power 4 minus minus plus 31. So 16 plus 31, which is equal to 47. So this is the right answer to the question. C option, correct answer to the question. Hope you got that. Let's move to the next question. Question number 7, let A be given by this set and B is this set. The total number of one-to-one maps for the function is to be such that f of 1 plus f of 3 is equal to 14 is. Here you are having two sets. This is A and B. A is having 1, 3, 7, 9, 11 and 2, 4, 5, 7, 8, 10 and 12. Here you are having 5 elements. 7 elements in this one. So this is your A and B. Next, what you have is f of 1 plus f of 3 is equal to 14. So here are the two cases possible. The first case, when f of 1 is equal to 2, f of 3 is equal to 12. Or when f of 1 is equal to 12 and f of 3 is equal to 2. So total one-to-one functions, how many? This is 2 into 5 into 4 into 3, which is 120. Let's see the second case when f1, let's say that is equal to 4 and f3 is equal to 10. So also f1 is equal to 10 and f4 is equal to 4. Again, how many one-to-one functions? 2 into 5 into 4 into 3. So the total cases will be given by 240. So this is the answer to the question, D option. Hope you got that. Let's move to the next question. Question number 8, if the function sine 3x plus alpha sine x minus beta cos 3x upon x cube, where x belongs to real numbers, is continuous at x is equal to 0, then f of 0 is equal to. You're having the function given by this and you're given that this is continuous at x is equal to 0. See, in that case, the limit x approaching 0, fx will be equal to f of 0 because the function is continuous. Function is continuous at x is equal to 0. It's given in the question. That would simply mean limit x approaching 0 sine 3x plus alpha sine x minus beta cos 3x whole thing divided by x cube. See, for the finite solution for this, that means this will be denominator will have a 0, this will be a 0, this will be a 0. But this is not a 0 because cos of 0 is equal to 1. So this will be minus beta upon 0. That means for limit to exist, beta should be 0. So then this limit will be given by limit x approaching this sine 3x alpha sine x whole thing divided by x cube. Or this is given by limit x approaching 0. This is 3 sine x minus 4 sine cube x plus alpha sine x divided by this limit. Here is 3 plus alpha sine x minus 4 sine cube x upon 3. See, again, for the finite solution, you need to have this will the denominator will have a 0 and this for the finite solution you need to have 3 plus alpha also equal to 0 for finite solution because this is having x cube and here is x. So this should also be equal to 0 for the finite solution, which gives you alpha is equal to minus 3. So if alpha is equal to minus 3, now the limit will be given by x cube minus 4 sine cube x upon x cube. You know limit x approaching 0 sine x upon x is equal to 1. This gives you answer as minus 4. So this is your f of 0 because the function was continuous at x is equal to 0. So that means you have D option as the correct answer. Hope you got that. Let's move to the next question. Question number 9. The integral of limit 0 to pi by 4, this whole expression dx is equal to. So you have this integral. Let's write it down once. You have 0 to pi by 4, 136 sine x divided by 3 sine x 5 cos x dx. So let's say sine x that's equal to a into 3 sine x is equal plus 5 cos x plus b into this 3 cos x minus 5 sin x. Let's write 136 sin x over here. I'm using fraction by parts over here. So using the fraction by parts, this can be written from here. The coefficient of, let's equate the coefficient of sin x and cos x on the LHS and the RHS. So you will have 136 is equal to 3a minus 5b. Also 0 is equal to 5a plus 3b. Let's solve both of them. You have 3b is equal to minus 5a, right? Or b is equal to minus 5 by 3a. Let's fill in this equation. So this gives you 136 is equal to 3a minus 5 into minus 5 upon 3a. That is equal to 3a plus 25 upon 3a, or this is 34a upon this 3. This is 136, and a will be given by 136 into 3 upon 34. This will cancel at 4, right? So 12 is the value of a, and b was equal to minus 5 upon 3 into a, which is equal to minus 20. So let's open this up. This integral now can be written as limit 0 to pi by 4. That was a 3 sine x 5 cos x divided by 3 sine x 5 cos x, limit 0 to pi by 4, b 3 cos x 5 sine x divided by 3 sine x 5 cos x dx. Right. So what is your a? 12. This gives me, let's take 12 outside, 0 to pi by 4, 1 dx. And let's take the b outside. B was equal to minus 20. And see, the numerator is the derivative of the denominator. So cos sin x derivative is cos x derivative is minus sin x. So this can be written as log of 3 sin x 5 cos x limit 0 to pi by 4. This gives me limit x 0 to pi by 4 minus 20 log of, let's fill in the values. You have 3 sine 5 by 4 plus 5 cos pi by 4 minus 3 sine 0 minus 5 cos 0. So this is 12 into pi by 4 minus 0 minus 20. This will give me 3 by root 2, 5 by root 2 minus 0 minus 5. Okay, so this is 3 pi minus 20, 8 upon 2 pi root 2 minus 5. Okay, I forgot to. Okay, wait. Here was the log, right? Yes. It was log over here, so this was supposed to be in the log again. Okay, let's redo this question from here again. I forgot to write the log, okay? Here was cos pi by 4. And now again the log of sine 0 cos 0. 3 sine 0, 5 cos 0. Okay, limits I have used. So this is 12 into pi by 4 minus 0 minus 20. This will give me log of root 3 upon root 2. log of 3 upon root 2, 5 upon root 2 minus log of minus 5 was plus. So plus 5, right? So this was minus over here. This is 3 pi minus 20 log of 8 upon pi minus log of this. This will give me 3 pi minus 20 log of 4 root 2 plus 20 log 5. This is 3 pi minus 20 into 5 pi 2 log of 2 plus this. Because 4 root 2 is equal to 2 power 2 into 2 power 1 by 2, which is 2 power 5 by 2. So log of 2 power 5 by 2 can be written as 5 by 2 log of 2. This gives me 3 pi minus 50 log 2, 20 log 5. This is the answer to the question. Now let's check with the options. 3 pi minus 50 log 2, 20 log 5. This option A. This is the right answer to the question. Hope you got that. Let's move to the next question. Question number 10, the coefficients of A, B, C in the quadratic equation. These are chosen from this set. The probability of this equation having the repeated roots is. So you have the quadratic equation ax square plus bx plus c is equal to 0, where A, B, C, they are chosen from this set. A, B, C, they belong to 1, 2, 3, 4, 5, 6, 7, and 8. Now, for the probability of this equation having repeated roots, so roots can be repeated. For repeated roots, you know the roots are equal, and that is the case when the discriminant is equal to 0. B square minus 4ac, this is your discriminant. This gives you b square is equal to 4ac. 4 is a perfect square and this. So that means for this to be true, this is already a perfect square. AC should be a perfect square as well, right? So what are the like A and C can have as an ordered pair? 1, 1, 1, 4, then 2, 2, 2, 8, 3, 3, 1, 5, 5, 6, 6, 7, 8, 2, and 8, 8. Corresponding B. Now, there is for this value of A and C, there is corresponding value of B. Now, that we also must lie in this set because you are having B square is equal to 4 into AC. So, for these values of AC, there are certain values of B, and that also should lie within this set only. So, let's see from here what A, B, C ordered pairs can have. So, it can have like 1, 1, this can have a 1, like C was 1. In that case, what will be B? It will be 2. When A is 1, C is 4, B will be 2. When A is 1, B is 4. When A is 2, B is 2, then sorry, A is 2, C is 2, then B will be equal to 2. Next, when A is 8, C is 8, then B will be also equal to 8. 3, C is 3, B will be equal to 6. When A is 4, C is 4, B will be equal to 4. And next 4A, 4C, 8 will be B. 4A, 4C, in that case, 8 will be your B. So these are the all the possible set of values for A, B, and C. Hope you understood this. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8. Now the probability says number of favorable cases upon total cases. 8 are the favorable cases and total cases will be how much? There are 8 sets. A can have A values, 8 values, B can have 8 values, and C can have 8 values. So it will be 8 into 8 into 8, or this will be equal to 8 cube, or 1 upon 64. This will be the answer to the question, right? Here you have C option as the correct answer. Hope you got that. Let's move to the next question then. Question number 11, let A and B be the two square matrices of order 3 such that A's determinant is 3 and B's determinant is equal to 2. You have to find out determinant of A transpose into A into adjoint of 2A inverse, adjoint of 4B, adjoint of AB inverse into A transpose, determinant. So determinant is starting from here till here. Now this can be written as a determinant. First of all, you are having this and this. And let's find out determinant of A transpose into A into adjoint to A inverse, right over here like this. And then adjoint of 4B, adjoint of AB inverse into A transpose determinant. So this can be written as, you know, the determinant of A and B. A multiply B is equal to determinant of A multiply determinant of B. This is equal to A transpose determinant into A determinant into adjoint of this. This can be written as 1 upon determinant of adjoint to A. This is multiplied by adjoint of 4B into 1 upon determinant of this, 1 upon determinant of AB into A's determinant into A transpose determinant. Okay, what is the determinant of A? It is 3. So if A's determinant is equal to 3, then A's transpose will also have the determinant as 3. So this gives me 3 multiply, this gives me 3 again, and 1 upon adjoint of 2A. This will give me like 1 upon what is 2 power. This will be, this is a 3 by 3 order matrix. So this is 2 power 6 into adjoint of A into 4 power 6 into adjoint of B determinant into adjoint of B adjoint of A multiplication into 3 because these two have the determinant as 3. So this gives me 9 into 1 upon this 2 power 6. Now adjoint of A, because A determinant, A was a 3 by 3 matrix. So adjoint of A determinant will be determinant of A raised to power 3 minus 1 into 4 power 6 into determinant of B raised to power 3 minus 1 into 1 upon determinant of B raised to power 3 minus 1 into determinant of A raised to power 3 minus 1 into 3, that is equal to 9. So this gives me 81 into 1 upon 2 power 6 into determinant of A was 3. So 3 power 2. This is 2 power 12 and this is determinant of B was 2. So this is 2 power 2 into 1 upon 2 power 2 into 3 power right into 9. Okay, we have already solved this. So let's do the cancellations. Here you have 2 power 6 and 2 power 4. This is 2 power 8 and this will give you 2 power 4 over here. And this is 9. So this will cancel it. So, like this. You have 2 power 6 which is equal to 64 as the answer. Option A. Hope you got that. Let's move to the next question. Question number 12, let a circle C of radius 1 closer to the origin be such that the line passing through this point and parallel to the coordinate axis touch it. Then the shortest distance of the circle C from the point 5, 5 is, let's say this is your circle. And according to the question, there is a point 3, this circle touches the lines through this point and parallel to the coordinate axis. First of all, let's make the lines which are passing through these lines and parallel to the coordinate axis. So this is the one. Here is your circle. This is the line y is equal to 2 and this is the line y x is equal to 3. And here is the radius. It's given in the question that this is equal to 1. This is also equal to 1. This is also equal to 1 and this is also equal to 1. Okay. Now, this is y is equal to 2 and this is 1 and 1, 2. So, and x is having 3. So 1, 1, let's say this is somewhat 1 over here. So here is your coordinate axis. This is your x-axis and this is your y-axis. Got it? So this is the figure for your problem. Now you have to find out the shortest distance of the circle from the point 5, 5. So here is your point. Somewhere around here is your point 5, 5. Right? Now let's see. This is the point. Let's say this is P, 3, 2. And this is the center of the circle. 3 comma 2, this is like 2 and this will have the y coordinate. This point, this is having the x coordinate as 2 and y coordinate as 1. So the center of circle, what is this? You can't solve this sum if until you draw the figure, because you will not be able to understand the scenario over here. So the coordinates of the center of the circle will be given by 2 comma 1, because this is like 1, this is 1 and this is 1, and here is the distance 1. Also, this one is distance 1. So the center of the circle is equal to 2 comma 1. And let's say this is the point Q. Let's find out the distance. First of all, let's find out the distance PC, because I have the coordinates for P and C as well. P is having the coordinates as 3 comma 2 and C is having the coordinates as 2 comma 1. So PC will be given by root of 3 minus, not sorry, I want to find out this, not PC. I want to find out. This is Q and let's say this is R. I want to find out RC. Okay, RC, R is having the coordinates as 5, 5. We are given in the question, and the C is having the coordinates as 2, 1. So RC will be given by root of 5 minus 2 square plus 5 minus 1 square. And this will be 3 square, which is equal to 9. 4 square, this root of 25. RC came out to be 5. But I need to find out the shortest distance from the circle to this point. So basically what I want to find out is this QR, right? RC is equal to QR plus QC, or QR is equal to RC minus QC. RC we just to solve, this is 5, and QC, you know, this is the radius of the circle, which is 1. The answer to the question is 4. Option D is the correct answer. Hope you got that. Let's move to the next question. Question number 13, let the line 2x plus 3y minus k is equal to 0 with k is greater than 0 intersect x and y axis at the points A and B respectively. If the equation of the circle having the segment A, B as a diameter is given by this. And the length of the latest rectum of the ellipse is this, is m by n. This is length of the latest rectum where m and n are the co-prime numbers. Then what is 2m plus n equal to? Fine. So here you have the equation. First of all, let's write down this equation of the circle. This is x square y square minus 3x minus 2y is equal to 0. This is your equation of the circle. And this is the equation of the line which intersecting x and the y axis at A and B. And the A and B is your diameter. So if A and B is your diameter, which are lying on this line, so this is equation of line of diameter. That is 2x minus 3y minus plus 3y minus k is equal to 0. From here, the center, let's find out. This is minus g minus f, that is minus half the coefficient of x and minus half the coefficient of y. So this is the center. This center lies, of course, the center lies on the diameter. So this point lies on the diameter. 2 into 3 by 2. 3 into 1 minus k is equal to 0, or you have k is equal to 6. There's the value. Now, let's pick up the equation of the ellipse. equation of ellipse is x square 9y square is equal to k square, which is equal to 36, or this can be written as x square upon 36, y square upon 4 is equal to 1, or x square upon 6 square, y square upon 2 square is equal to 1. So that means what is your A and B over here? A is 6, B is 4. If I compare it with the general equation for the ellipse, x square upon a square, y square upon b square is equal to 1. So a is equal to 6 and b is equal to 4. Now, length of latest rectum for ellipse is equal to 2b square upon a. So 2 into 4 into 4 upon 6, which is equal to 3, right? 8 upon 3. And now this was equal to m upon n. Now you have m as 8, n as 3. You had to find was 2m plus n, 2 into 8 plus 3, which is equal to, wait, 16, right? I did a mistake. This was, B was 2, not 4. So it was 2, it was 2, it was 4, and this is this, and here you have 4. Let's do this again. 2 into 4 plus 3, you have 11 as the answer. Okay, so here you have option B. This is the right answer to the question. Hope you got that. Let's move to the next thing. Question number 14, consider the following two statements. First statement is for any two non-zero complex numbers Z1 and Z2. This is true. And statement 2 says x, y, z. If there are three distinct complex numbers, A, B, and C, three positive real numbers such that this is true, then this is true. Okay, this is your first statement. This is your second statement. So you have to prove this is correct and or statement 1 and 2, like which is true and false and all that. So let's pick up the first statement. Here you have this statement. Let's write it. You have modulus of Z1, Z2 plus is equal or not is equal to, it's in multiplication with the Z1 divided by modulus of Z1 plus Z2 divided by modulus of Z2. Modulus. Now you know one thing, since modulus of Z1 upon modulus of Z2 plus Z2 upon modulus of Z2 is less than equal to modulus of Z1 plus modulus of Z1 upon modulus of Z1 whole modulus plus this, right? And I can write it like this. This one will be written as modulus of this upon modulus of this plus Z2 modulus upon Z2 modulus, right? So this is it. This is what this is equal to, less than equal to 2. So which means your modulus of Z1 upon modulus of Z1 plus Z2 upon modulus of Z2 whole modulus is less than equal to 2. And so now let's pick up this one again, where we started from. Therefore, modulus of Z1 plus Z2 into modulus of Z1 upon this, Z2 upon this is less than equal to 2 into this. So that means your first statement is correct. Okay. Now let's go for the second statement. Here you have the second one. It is given that A upon y minus z modulus, B upon this modulus, C upon this modulus. A upon y minus z modulus is equal to B upon this is equal to C upon this modulus. Let's square them. You have A squared upon lambda minus z squared. This is equal to this is equal to this. Let's say this is equal to some lambda. Sorry, here was y, not lambda. Okay. So this is equal to some lambda. Here gives you a squared is equal to lambda into modulus of y minus z square. This is equal to lambda y minus z into, this can be written like this, right? And similarly, b squared will be written as lambda into z minus x modulus square, which is equal to lambda into z minus x into z modulus minus x modulus c squared will be equal to lambda into x minus y into x conjugate minus y conjugate. Okay, so let's add all of them. You will have, let's add them. This thing and c square. This is asked in the question, right? Over here, from here. So let's add the LHS. From here, you will get this will be equal to lambda into y conjugate minus z conjugate minus x conjugate minus y conjugate. This is equal to 0, right? That means this is in the question, it is given that this is equal to 1. But the answer we got is this is equal to 0, which means statement 2 is wrong. That means statement 1 is correct, but statement 2 is incorrect. Option C is the right answer. Hope you got that. Let's move to the next question. Question number 15. Suppose theta lies between this interval. This is a solution for this equation. You have to find out the value for cos theta. Here is the equation given. Cos is available here, but I have sin theta also here. Let's try and get rid of the sin theta. Let's write down the equation. You have 4 cos theta minus 3 sin theta is equal to 1, or 4 cos theta minus 1 is equal to 3 sin theta. The best way to get rid of sin theta and come into the cos theta is applying this identity. Sin square plus cos square is equal to 1. This is our lifesaver in the whole trigonometry. So you have 4 cos square theta. Let's square to both sides. This is equal to, here was, sorry, sin theta, not sin square theta. Okay. This is equal to 9 sin square theta. Correct. And let's open, you have 4 cos square theta plus 1 minus 8 cos theta is equal to 9. Let's write it as 1 minus cos square, which is equal to 9 minus 9 cos square theta. This is 4 cos square theta minus 8 cos theta plus 1. That is equal to 13 cos square theta minus 8 cos theta minus 8 is equal to 0. Wait, here was supposed to be 16, right? And this was 25. Let's rewrite it. You have 25 cos square theta minus 8 cos theta minus 8 is equal to 0. Applying the quadratic formula, x is equal to minus b plus minus b squared minus 4ac upon 2a. This is a, this is b, this is c. So your cos theta is equal to minus plus minus root of b squared, which is minus 8 squared, that is 64, minus 4ac divided by 2a. You have 8 plus minus 64 plus, this is 800 and divided by, this is 8 plus minus root of upon 50, or 8 plus minus, this is 16 into 54 upon 50, which is 8 plus minus 4 root this upon 50. Divide the numerator and the denominator by 2. You have 2 plus minus, you have 4 plus minus 2 root 54 upon 25. I think this is it. Okay. You're given that theta lies between 0 to pi by 4. So that means you have given This was your cos theta. Now theta lies between 0 to pi by 4. So what I'll pick is the value 9 fours are right. Okay. So cos theta will be equal to this will lie the this will have a positive value because it is lying in the first quadrant. In the first quadrant, it is positive, so it will give me 4 plus 2. 54 can be written as 9 6 right. So it will be 3 root 6 divided by 25 or 4 plus 6 root 6 divided by 25. Let's check with the options. I don't have any such option. So let's try and do one thing. This is root 6 minus 2 or plus 2 in the denominator. And let's do this thing. You have cos theta is equal to 4 plus 6 root 6 upon 25. Let's multiply the numerator and the denominator by. Let's do it this way. Multiplying the numerator and the denominator by 2. So you will have here 2 into 4 plus 6 root 6 upon 50. This will be 4, 2 plus 3 root 6. 50 can be written as 50 minus 4, or this will be like this 50. I want to get somehow in this term. Okay. Sorry, this term 3 root 6. So this is 3 root 6 square minus 2 square, or you have 4 into 3 root 6 plus 2 upon this is a square minus b square. So a plus b, a minus b, these two will cancel and you will have 4 upon 3 root 6 minus 2. This is the answer to the question 4 upon 3 root 6 minus 2. We have first option as the correct answer. Option A is the right answer to the question. Hope you are clear with this. Let's move to the next question. Question number 16. If 1 upon root 1 plus root 2 plus 1 upon root 2 plus root 3, so on till 1 upon root 99 plus root 100 is equal to m, and this expression is equal to n, then the point mn lies on which of these lines? So you have to find out the values of m and n. Let's write down m is equal to 1 upon this plus 1 upon this. So on till 1 upon 99 root plus root of 100. This is equal to m. And okay, let's do one thing. Let's rationalize the denominator. So you have here root 2 plus root 1, root 2 minus root 1 like this, plus 1 upon root 3 plus root 2 into root 3 minus root 2 upon root 3 minus root 2, so on till root 100 minus root 99 upon root 100. This and here was, this is multiplied by root 100 plus root 99. Okay, so this gives me root 2 upon 1 upon root 2 square minus 1, which is equal to 1, plus root 3 minus root 2 upon 1, so on root 100 minus root 99 upon 1. This is equal to m. So this makes root 2 minus root 1 plus root 3 minus root 2, so on root 100 minus root 99 is equal to m. So that means you will have the cancellations like this will cancel, and similarly here will be root 4 minus root 3. So this will also cancel. So everything will be cancelled. Ultimately, you will be left with minus of root 1 plus root 100. This is equal to m. So this is equal to 9. I got the m as 9. Let's pick up for n. Now your n was 1 upon 1 into 2 plus 1 upon 2 into 3. So on 1 upon 99 into 100. This is equal to n. And see, now this I can write it as 2 minus 1 upon 1 into 2. Or let's say 2 minus 1 upon 2 into 1 plus 3 minus 2 upon 3 into 2. So on 100 minus 99 upon 100 into 99. That's equal to this. So this is 1 upon 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3. Similarly, 1 upon 3 minus 1 upon 4 will be the next one. So on till 1 upon 99 minus 1 upon 100. That is your n. So again, there will be these cancellations, and 1 upon 99 will also get cancelled. You will have 1 minus 1 upon 100 as the value of n. So this n is equal to 99 upon 100. Now the point mn becomes 9 and 99 upon 100. Now, let's check with which of these lines is being satisfied. 11, let's write the lines, equations of the lines. First one, 11, x minus 1 minus 100, y minus 2. Or let's go for this. So this is 11, 9 minus 1 minus 100. This is 99 upon 100 minus 2. Okay, this should be equal to 0. So this is 88 minus 100, 100 will cancel, and 99 plus 200, and this is of course not equal to 0. So let's drop it here. B option, this is 11x minus 2 minus 100 y minus 1 is equal to 0. So 11 into 9 minus 2 minus 199 upon 100 minus 1 is equal to 0. This gives me again 77 minus 100 into this will be minus 1 upon 100, which is not equal to 0. So B is not also the option. C part, this is 11x minus 1 minus 100y. So 11 into 9 minus 1 minus 100 into 99 upon 100. This gives me 88 minus 99. This is not equal to 0. The D option. The last one, 11x minus 100y. So 11 into 9 minus 100 into 99 upon 100. So this is equal to 0. That means D option is the right answer because this is satisfying the given point M and N. Hope you're clear with this. Let's move to the next question then. Question number 17, let fx be equal to this equation x power 5, 2x cubed, 3x plus 1, where x belongs to real numbers, and gx be a function such that g of fx is equal to x for all real numbers x belongs to. We have to find out the value of g7 upon g dash 7. Fine. You have fx is equal to x power 5, 2x cubed, 3x plus 1. So what is your f dash x? This is 5x power 4, 6x squared plus 3. And f dash of 1, this will be equal to 14. Now you're given that g of fx is equal to this. So what is the derivative of g function? G of this is equal to f dash x, right? It will come in the denominator, right? Because we have to find out the derivative of this. Yes, it will be 1 upon f dash of x. Now, for fx, because you have to find out the g of 7. So that means g of fx, right? That means fx is equal to 7. For fx is equal to 7, you have x power 5 to x cubed 3x plus 1 is equal to 7. Or let's take x common from here. You have x power 4 to x squared plus 3 minus 6 is equal to 0. This is possible only when x is equal to 1. Right? So when x is equal to 1, so that means that g dash of 7 will be equal to 1 upon f dash of 1. Right? Because this will give you 7 value when you will have x is equal to 1. Correct. So this is equal to 1 upon f dash of 1. What is your f dash of 1? That was equal to 14. We calculated that. So 1 upon 14, this is your g dash of 7. Now you have to find out g7 upon g dash of 7. What is your g7 equal to? G of 7 will be equal to when your fx will be equal to 7. And when was your fx is equal to 7? It was 7 when x is equal to 1. Correct? So g of 7 will give you, because this is equal to x, this will be 1 upon 14. 1 upon 14. This will be 1 because g of 7 was equal to x, right? Remember? So fx will be equal to 7 when x is equal to 1. So that means g of 7 will be equal to 1. And g dash 7 we already calculated. This is 1 upon 14. So 14 is the right answer to the question. This is the answer. Option D is the right answer. Hope you're clear with this. Let's move to the next question. Question number 18. If A, B, C, D, they are the vertices of the quadrilateral A, B, C, D, then its area is. So you're given the 4 coordinates. You have to find out the area. Okay. So this is the, this be the quadrilateral, any shape it can have. Let's say this is your A, 1, minus 1, 2. Let's say this is B, 5, 7, minus 6. And C, 3, 4, minus 10. And this is your D, minus 1, minus 4, and minus 2. Now, area of the quadrilateral ABCD will be given by, let's say this is the diagonal area of ABCD quadrilateral is equal to area of triangle ABC plus area of triangle ADC. Now, in triangle ABC, what is AB? If I write it in the vector form, AB in the vector form, the direction ratios will be given by 5 minus 1. Okay, let's write it as 4i, 8j, and this will be minus 8k. And the BC vector, it will be given by minus 2i, minus 3j, minus 4k. So the product of let's find out first of all the product of AB and BC vector. This cross product, this will be I, J, K, 4, 8, minus 8, minus 2, minus 3, and minus 4. Let's solve it. This will be given by I, minus 32, minus 24. Okay, minus J, minus 16, minus, wait, J is the minus 16, minus 16. And here will be K, which is minus 12, plus 16. This will give me minus 56I, plus 32J, and 4K. Now the area of ABC, area of triangle ABC, this is given by half the magnitude of the cross product of the AB and BC. So this is equal to half of 56 square minus 56 square, that's equal to 56 square only. Okay, 32 square plus 4 square. This will give you solving 4176, or this is 12 upon this upon 2, 6 root of 29. Right. Now let's consider triangle. Let's take triangle ADC. And here you have AD vector as minus 2i, minus 3j, minus 4k. And BC 4i, 8j, 8k. Let's find out the cross product of both these vectors, AD and DC. This is I, J, and K. This is minus 2, minus 3, and minus 4, 4, 8, and minus 8. This is I cap minus 24, 32. This is 2, minus 3, minus 4, 4, 8, and minus 8. Okay, this is 24, positive, not negative. And minus j, this will be 16 plus 16 plus k. This will be minus 16 plus 12. Right, so this is 56 I, 32 j, 4k. Now area of triangle ADC. This is given by half the magnitude of the cross product of AC and AD and DC. This is half into root of 56 square minus 32 square and minus 4 square. Same thing. Same one you got. This is root of 4176. 12 into root of 29, or this. Now, area of the quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ADC. This was root 6 root 29 and this was also the same. This is 12 root 29. This is the answer to the question, 12 root 29 square units. Here you have first option as the right answer. Hope you're clear with this. Let's move to the next question of this paper. Question number 19, you have to find out the value for this integral. Let's go. Let's say this is equal to I. So I is equal to integral of minus pi 2y 1 plus sine y whole thing divided by 1 plus cos square y. Cos square y into dy. Let's open it up. This can be written as integral minus pi 2y upon this plus 2y into sine y upon 1 plus cos square y. Limits minus pi to pi. Now, this is an odd function. Look at it. Yes, this is an odd function. And this is even. So that means this integral will be equal to 0 plus this 2 I'm taking outside. At the same time, see, this is an even function. So this can be written as 2 into 2. Limits will change 0 to pi because minus pi to pi, I can write it as like twice of 0 to pi. Because this is an even function. For the odd functions, it will be 0. This 2 I have taken outside. Here will be y into sine y upon 1 upon cos square y dy. Right. Now let's apply King's rule. You know that is integral of a limits a to b fx dx is equal to integral limits a to b f of a plus b minus x dx. So applying the King's rule, this I will be given by 4 and here will be 0 plus pi minus y. So this will give me pi minus y. Sine 0 plus pi minus y. Again, this thing 1 plus cos squared 0 plus pi minus y. This will be this. Right. So this I is equal to 4 and yeah. So this will be pi into, what is sine pi minus y? Sine will not change because 180 degree does not change the trigonometric ratio. It will remain sine. Second thing, pi minus y lies in the second quadrant. So the sign will be positive. So it will remain as sine y only. This is sine y upon 1 plus this will remain cos pi minus y. This will give me cos of minus cos of y. Now, because of the square, it will be positive thing only. Correct? And here you have minus integral 0 to pi, the limits were 0 to pi y into sine y upon 1 plus cos square y into dy. Right. So what is this equal to? Just think where we started from. This was equal to your I. See? Let's see, this is 1. So from 1, here was 4 also. From 1, you have I is equal to 4 integral 0 to pi into pi. Let's write down outside only. So sine y upon 1 plus cos square y into dy. And this was your I from 1. This gives me 2I is equal to 4 pi, this thing, right? 1 plus cos square y into dy. This will cancel. I is equal to 2 pi. Now let's find out the integral of it. This is the integral is tangent inverse of cos y, right? Because this is like the variable thing and the numerator is having the derivative of cos y. So this is tangent inverse of cos y and the limits were 0 to pi. 2 pi minus it will be over here. So this is now minus pi by 4 minus pi by 4, right? Hope you got that, like what I have done. This is tangent inverse of, let's redo it from here. Wait. So this is minus tangent inverse of cos pi. Cos pi is equal to minus 1. Minus minus plus, it will be over here. Tangent inverse of cos 0. Cos 0 is equal to 1. This gives me 2 pi. So this will be given by, here was minus, right? Yes, okay. So this will be minus of minus pi by 4 plus pi by 4. This is 2 pi and here will be 2 pi by 4 or this will be pi square. This is the answer to the question, pi square, option A. Hope you're clear with this. Like what I have done over here in the last one, this was tangent inverse cos y. And let's fill in the limits. Cos pi was equal to minus 1 and cos 0 was equal to 1. So that is why you got the answer as pi squared. Hope you got that. Let's move to the next question. Question number 20, if the line 2 minus x upon 3 is equal to 3y minus 2 upon lambda plus 1 is equal to this, makes a right angle with this line. You have to find the value of 4 lambda plus 9 mu. So this is 2 minus x upon 3, 3y minus 2 upon 4 lambda plus 1, 4 minus z. This is the line. So let's make it correct. Let's take the x on the positive like coefficient. This will be x minus 2 upon minus 3 is equal to y minus 2 by 3, whole thing divided by 4 plus lambda, 4 lambda plus 1 upon 3. This is equal to z minus 4 divided by minus 1. Let's say this is your equation 1. And the second one is this. Now, x plus 3 upon 3 mu, 1 minus 2y upon 6, 5 minus z upon 7. This is your second line. Again, this can be written as x plus 3 upon 3 mu. Let's make the y coefficient as positive 1. And this is y minus 1 by 2 upon minus 3 is equal to z minus 5 upon minus 7. Now, they both are making right angle with each other. That means now 1 and 2 is 1 and 2. They make a right angle with each other. So what does that mean? That means minus 3 into this plus this into this plus this into this is equal to 0. Therefore, minus 3 into 3 mu 4 lambda plus 1 and 3 into minus 3 minus 1 minus 7 is equal to 0. This gives me minus 9 mu plus, no, not this will be minus 4 lambda minus 1 plus 7 is equal to 0. Or you have minus 9 mu minus 4 lambda plus 6 is equal to 0. This is what we needed to find. 4 lambda plus 9 mu. This is equal to 6. This is the answer to the question, option D. Hope you're clear with this. Let's move to the next question then. Question number 21, from a lot of 10 items, which include 3 defective items, a sample of 5 items is drawn at random. Let the random variable x denote the number of defective items in the sample. If the variance of x is given by this, then 96 omega square is equal to. Fine. So let's try and make the table for it. First of all, you are having x, which denotes the number of defective items, which include 3 defective items. That means the first one is no defective item. 1 and 2 and 3 is withdrawn. And for this, let's say the probability of this to happen like the 0 ones are withdrawn. See, out of 10, if 3 are defective, then how many are correct ones? 7 will be correct one, the right ones. So out of, see, you have total is what? 10 items. You have to pick up how many items? 5 items you have to pick up. So out of those which are withdrawn, 10C5, let's say the 7, it is withdrawn, the 7, like nothing defective is withdrawn. All the items are good, which is 7C5. This gives me on solving. Okay, I'll solve that later. First of all, let's write down. Now, for example, 1 defective item is selected. This gives me that out of 7 correct items, 4 are selected, and out of 3 defective, 1 is selected. Now the total 10 are selected, 5 are selected from 10. Similarly, over here, this will be 7C3 into 3C2 divided by 10C5. And this will be given by 7C2, 3C3, 10C5. Right. I hope you can do the calculations now. 7C5 upon 10C5 on solving, this will give you 1 upon 12. On solving, this will give you 5 upon 12. And on solving, this will give you 5 upon 12 and 1 upon 12. Okay, like this. Here you are. This one. Right. So what is your x into px? It's the product of both of them. This will be given by right. So 0 into 1 by 12, this gives me 0, 5 by 12, 10 by 12, and 3 by 12. Okay. Now, what you are asked in the question, from the lot of this, let the random variable. If the variance is this, you have to find out 96. Okay. So first of all, let's find out mu. That's given by summation of x px, which is this. And you will have this as 5, 10, 3, which is 3 by 2. Now the variance is equal to, it's given by summation x minus mu square into px, which is equal to summation x minus 3 by 2. We just calculated this px. That is equal to, what is your x? It was 1 by 12 minus 3 by 2. Let's solve it here. 1 by 12 minus 3 by 2. It will give me 1 minus, sorry, it was 0. It was x. X was 0. So this will be 0 minus 3 by 2 square, which is equal to 9 by 4 into px for that was equal to 1 by 12 plus the next one, x was equal to 1. So 1 minus 3 by 2, it will give you minus 1 by 2. Minus 1 by 2 square is 1 by 4 into px. See over here, the px was equal to this 5 by 12. Correct? And this was for the first, second, and let's go for the third one. For the third one, you have x is equal to 2. So 2 minus 3 by 2, it will give you 1 by 2. 1 by 2 square, again 1 by 4 into 5 by 12. Because here the px was equal to 5 by 12. Plus the last one. This is when x is equal to 3. So 3 minus 3 by 2, it will give me 3 minus 3 by 2. It will give me 6, 3 by 2. Okay, so that's equal to 9 by 4 again. And the px was 1 by 12. Let's solve it. Let's take this is equal to 9 by 48, 5 by 48, 5, 9. Okay, here you have 9 plus 10 plus 9, 48, 18, and this is 28 upon 48. But this will give me 7 by 12, right? That was equal to your variance. This is, you have to find out 96 into variance, that is equal to 56, right? So you have 56 as the right answer to this question. Hope you understood this. Let's move to the next question. Question number 22, if the constant term in the expansion of this expression is p, you have to find out what is 108p. Fine. First of all, let's pick up this thing, this term. 3 by 2x square minus this raised to power 9. The general term TCR is given by here in this one. This is given by 9CR into the first one is 3 by 2 x squared raised to power this into raised to power r. So this is equal to NCR into 3 power 9 minus r upon 2 power this into minus 1 raised to power r x raised to power 18 minus 3r, or this is equal to NCR 3 power 9 minus 2r, 2 power 9 minus r, and let's write it like this. X power 18 minus 3r. Right. Now let's put, because I want this to be 0 for the x coefficient to be equal to 0. For the constant terms, you need the 0 x coefficient term. So let's put x is equal to 0 to get coefficient of x raised to power 0. So I put r is equal to 6. It will be given by 6 into 3 power 9 minus 12, which is minus 3 upon 2 minus 2 power 3 into minus 1 power r, not x. Okay. So this is 6 and x power 18 minus 18. This is equal to 9c. 6, 1 upon, this will give me 6 power 3. Yes, that's it. Into x coefficient 0. So this is, on solving, this will give you 7 upon 18 into x raised to power 0. Now let's put r is equal to 0. Why? To get coefficient of x raised to power minus 3. This will be equal to 9c7 into 1 upon, wait, 3 upon, it was 9 minus 2r. So 9 minus 14, 2 power 2 into minus 1 raised to power 7 into x raised to power 18 minus 21. This is 9c7 multiply 1 upon 3 upon minus 5 on this into minus 1 into x raised to power minus 3. Or on solving this, the whole thing, you will get the answer as minus 1 by 27 into x raised to power minus 23. Now let's get back to our expression which was given to us. It was 1 plus 2x minus 3x cube. Whole thing divided, multiplied by 7 upon 18 x power 0 minus this. Right. So I have picked up the these two terms only from the whole thing because I want the constant term. And why x power 3? Because I want to cancel this one as well. Okay. So this will give me 7 by 18 plus 3 by 27. On solving both of them, only the constant part, because this is constant and this is constant and this is x raised to power 3 and this is x raised to power minus 3. So both of them, I'm interested only in these two terms. So I'll pick up only these two terms. I'm not concerned about the rest of the terms, right? So ultimately, let's solve it. 18 and 27, the LCM. First of all, this is 9, right? Okay, now it's quite easy. So 7 LCM is 18. 7 plus 2, you have 1 by 2. This is the answer. Okay, no, this is your P. What I want to find out was 108P. So 54 is the right answer to the question. Hope you got that. Let's move to the next question then. Question number 23. The area of the region enclosed by these two parabolas is. Fine. So you're having these two parabolas. The first one is y is equal to x squared minus 5x. And the second one is y is equal to 7 minus this. Let's say this is equal to, this is fx, and to differentiate between them. And this one is your gx function. Let's find out the point of intersection. For point of intersection, both will have the same values for the x and y. So that means, let's find point of intersection x square minus 5x, 7x minus x square, 2x square minus 12x is equal to 0, or 2x minus 6. So the 2 points are for the x are 0 and 6. The corresponding y points, y is equal to x square minus 5x. So here the y will be 0, and x square, I'm using this x square minus 5x. So x square, which is 36, minus 30, which is again 6. So these are the 2 points of intersection. Let's plot the graph. So here is your gx, because both of them, they are passing through the origin. Okay, so this is not the exact one. Anyways, this is your fx, this function, and this one is your gx. And this is the point of intersection 6, 6. And here is your 0, 0. This is gx, and this is your fx function. You have to find out this shaded area. Okay, we have everything now. So super easy. Let's go to find out the area ultimately required. Area is equal to integral. Limits will be 0 to 6 gx minus fx dx. So let's write down the gx and fx now. This is 0 to 6. Your gx was 7x minus x squared, and fx was this dx. 0 to 6. It will be minus 2x squared plus this thing. Okay, easy now. So this is minus 2x cubed upon 3, 0 to 6 plus 12 outside x squared upon 2, 0 to 6. I'm taking minus 2 by 3 outside x cubed. This simple thing now, 6x squared this. So you have minus 2 by 3 into 6 cubed. Right. And plus 6 into 6 square. So you have 6 cube common. This will be 6 cube will be taken common, and this will be 1 minus 2 by 3, or this will be 1 by 3 into this, or it will be 1 by 3 into 6 into 6 into 6, which is 72. So 72 square units, this is the area. Okay. Hope you're clear with this. 72 square units. Don't forget to write these small things because they matter a lot. So that's all for this question. Let's move to the next one. Question number 24. The number of ways of getting a sum of 16 on throwing a dice 4 times is. All right. So first thing, let's say this. There's the 4 throws: x1, x2, x3, and x4. These are the 4 throws. Now, in the first throw, you can have the values like between 1 and 6. In the second row also you can have the values between 1 and 6. Third and the fourth row. So this can have 6, 6, 6 and 6 values. So we want what? We want the sum of 16 on throwing 4 dice. In this particular question, I'll be using the concept of multinomial theorem. All right. So first thing, that means you have x bar 1, like second, 2, 3, 4. These are the outcomes of each and every throw. So there are 4 throws for this, so raised to power 4. This is 1, 2, 3, 4. For them, this is raised to power 4. And what we are interested in is only when you get the coefficient of, we are interested only in the coefficient of x raised to power 16 in this whole expansion. Let's go for this. See, this is, first of all, this is an AP series with the, this is an, GP series with the first term as x and the common ratio also as x. So the sum is given by a into 1 minus r raised to power n upon this. So this is a is x, 1 minus x power 6 upon 1 minus x, this whole thing raised to power 4, or this will be equal to x power 4, 1 minus x raised to power 6, this 1 minus this. Okay. Now, next, let's expand this one. You have x power 4. Let's keep it outside. This will be 1 minus, this will be minus 1 raised to power. Okay, this will be minus 1 only, minus 4 into x power 6 plus 6 into x power, it will be 12, so on. I'm not, I won't be taking any further values because we are interested only in the coefficient of x power 6. So this is x power 4 already, and this is x power 12. Let's finish it over here. We don't need the further terms. Now, this is 1 minus x raised to power minus 4. Let it be like this only for the time being. And this can be x power 4 minus 4 into x power 10 plus 6 into this. Now, see, we already have a x power 4, x power 16. What I need is the only coefficient of x power 12 from here, x power 6 from here, and x power 0 from here. I need only these 3 coefficients. Let's pick up those coefficients. Okay, in the expansion of this, any like this, you know the general term, it is n plus 1 minus CR. This is given like this. So I want the R to be over here as 12. I need this 12 over here. So this will be given by, first of all, this 1 will come over here. Right, because I'm interested in the coefficient of x power 0. X power 0 is this 1 only. So this one will come over here. Next is n is equal to 4 and r is equal to 12. For this one, you have n4, r12. So this will be given by 15c12 into x power 12 plus. Similarly, for x power 6, this is your r is equal to 6. So this will be 4 plus 6 minus 1. This will be 9c6 into x power 6. I won't be taking any further values. We are not interested because we want only x power 16. I'm saying this again. Okay, now let's multiply only the ones we are interested in. So this is 6 into x power 16. Let's keep the x power 16 outside now. So the very first one will be 6 over here. And then this is 12, right? So this is x power 4 and this is this. So this will give me 15c12. And minus 4 into, because this will be multiplied with this one, 4 into nc6. This is the one. Let's solve. You have 6 plus 15 factorial, 12 factorial, 3 factorial, minus 4 into 9 upon 6 factorial into 3 factorial. X power 16, right? I think we can ignore this because we want only the coefficient. So this will be 6 plus 15, 14, 13 upon 6 minus 9, 8, 7 upon 6. This will be 6 plus 5 and 7. Okay. This will be 6 plus 35 into 13. This is 9, 5, 444, 55. And on solving this is right 12 sevens out. I'm doing something. 987 into 4 is missing. Yeah, into 4 also was there. So on solving this, you will get minus 336. So this comes out to be 125. This is the answer to the question, 125. Hope you got that. Let's move to the next question. Question number 25. If S is a set for all the elements A which belong to the real number such that modulus of 2A minus 1 is equal to 3 into this plus 2 into this, where the square brackets represent the greatest integer less than or equal to t, and curly brackets t represents fractional part of t. You have to find out 72 into this expression. So you have a S such that A belongs to real numbers, to A minus 1 is equal to 3 greatest integer, 2 fraction part. Okay. So let's pick it. You have 2A minus 1 is equal to 3 this plus 2A. Right. This can be written as, this fractional part can be written as A minus greatest integer, right? So 2A minus 1 is equal to, this will subtract with 2 square brackets A. Let's write it down. Minus this plus 2A. So this is this. All right. So now there are two cases. Case 1, when A lies between 0 and 1 by 2. So in that case, 1 minus, because this is 0 to 1 by 2, so 1 minus 2A will be equal to 0 plus 2A. You will have the A's value as 1 by 4. Second case, when A lies between 1 by 2 and 1. So in that case, you will have 2A minus 1 is equal to this. No solution because the 2A, like 0 plus 2A cannot be equal to this. So you have no solution over here. Third case, when A lies between 1 and 2. So this will be 2A minus 1 is equal to 1 plus 2A. Again, this cannot have any solution. So that means this is the only possible solution. A is equal to 1 by 4. So what you had to find out was this. Let's pick it up. To find was 72 submission A belonging to S, this. So 72 times this 80. This is the right answer to the question. Option? No option actually, sorry. We have this answer. Hope you got that. Let's move to the next question. Question number 26. Let f be a differentiable function in the interval this such that f of 1 is equal to 1 and limit of this function is equal to 1. For each x greater than 0, then the value for this expression is equal to. You have a limit t approaching x, t square fx minus this thing upon t minus x. This is equal to 1. So if you put limits t approaching x, this will be 0 upon 0 form. That means you have to apply L'Hospital's rule over here. That makes limit t approaching x, it will not change. 2t, it will be 2t, and fx will not change. This will be the same, minus x square into f dash t upon 1. This is equal to 1. Or let's approach it. So you will have 2x fx minus this is equal to 1 only, right? Or you have x squared f dash x is equal to 2x fx minus 1. This can be written as dy by dx is equal to, or x square into this is equal to minus 2, and I'm putting fx as y, and f dash x as dy by dx. So x into y minus 1. Here's my final list. Okay. So you have a d square dy by dx is equal to 2xy upon x squared minus 1 upon x squared. Okay. Or dy upon dx minus 2xy upon x squared is equal to this dy by dx minus 2 upon xy is equal to this. Here, let's find out using this equation. I will go for the finding the integrating factor, which is given by e raised to power minus 2x, 2 upon x. Minus I'm taking outside, and this will be e raised to power minus 2, 1 upon x dx. This is equal to e raised to power log of x, or this will be e raised to power log of x raised to power minus 2, which is equal to this 1 upon x squared. Okay. And all right. What next? Now here, let's fill the equation. I got the integrating factor, which is given by y into integrating factor is equal to integral of, what was here? It was minus 1 upon x squared into your integrating factor plus c. So you have y upon x squared is equal to integral of minus, I'm taking outside this, dx plus c. Let's solve it. You have minus this plus cy upon x squared. Y upon x squared is equal to minus, this will be x raised to power this upon this plus c, or y upon x squared is equal to, this will give me plus 1 by 3 into 1 upon x plus c. Correct. Now you are given one more thing in the question. F of 1 is equal to 1. So that means when x is equal to 1, y is equal to 1. So 1 upon 1 is equal to 1 upon 3 plus c, or c will be equal to 2 by 3. So that means what your equation now becomes? The equation will be y is equal to 1 by 3x cube into x square plus c. C was equal to 2 by 3 into this. This makes it 1 by 3x plus 2 by 3x square. Okay. So now let's compare it with this one. Over here, 2f2 plus 3f3. So this was your y, or you can write it as your fx only. You had to find out 2f2. This was to find 2f2 plus 3f3. So let's find out f2 first. F2, if I'm putting x is equal to 2, this will be 1 by 6 plus 2 by 3 into 4. Or this will give me 1 by 6 plus 8 by 3. 6, 1 plus 16 or 17 by this. 17 by 3 it will be, because I will multiply it with 2. So plus 3 into, let's find out F3 also. This will be given by 1 upon 9 plus 2 upon 2 into this upon this. This will be 1 by 9 plus 6. This will be 55 upon 9. So this will give me 55 upon 3, or 272 upon 3. This will be 24. So this is the answer to the question 24. Hope you got that. Let's move to the next question. Question number 27, let A1, A2, A3, so on be the AP of positive terms. And AK be given by A1 minus A2 squared plus A3 minus A4, so on till A 2k minus 1 square minus a2k square. Also, you're given a3 is equal to this, a5 is equal to this, and a1 plus a1 square, a2 square, a3 square, the sum of them is equal to 66. You have to find out the value for this expression. Okay, so first thing you are having, this is your AP, A1, A2, A3, so on. So nth term here will be given by first term, AP nth term is given by first term into plus n plus 1. Sorry, first term plus n minus 1 into d, where n belongs to the natural numbers. Also, you have here ak is equal to a1 square minus a2 square plus a3 square minus a4 square, so on a 2k minus 1 square minus a2k square. This can be written as a1 plus a2 square, or a1 minus a2 into a1 plus a2 plus a3 minus a4 into a3 plus a4, so on till a2k minus 1 minus a2k into a2k minus 1 plus a2k. So see, this is an AP. That means D will be equal to A2 minus A1, and this is equal to A3 minus A2, or A4 minus A3, right? This is the common difference. So this can be written as minus D into A plus A1 plus A2 minus D A3 plus A4, so on, minus D A2K minus 1 plus A2K. Let's take minus D common from everywhere. You will have minus D into A1 plus A2 plus A3, so on till A2K. This is the sum of this AP, and sum of AP is given by n by 2 2a plus n minus 1 into d. So this is equal to minus d, n in this case is 2k upon 2, 2a1 plus k minus 1, 2k minus 1, because this is 2k into d. This is equal to minus 2 and 2 will cancel. So this will be minus d k 2a 2k minus 1, a1 actually, and d, right? So this is your general term AK. And you are given in the question A3 is equal to, it is minus 153 and minus 153, and A5 is equal to minus 435. So using this thing, you have K is equal to 3 in this case. This will give me minus D into 3 2A plus 5D is equal to this, right? Or this will be minus 3D dividing both sides by minus 3. You will have D into 2A plus 5D is equal to 51. Let's say this is 1. Also A5, this is equal to minus 5D into 2A plus 9D is equal to minus 435. Dividing both sides by 5 minus 5, this is D into 2A plus 9D will be equal to 87. Right. So let's open this. 2AD plus 9D square is equal to 87. 2AD plus 5D is equal to 51. From here, you have 2AD is equal to 51 minus 5D. Let's fill in this equation. So 51 minus 5D square it was, right? So minus this plus this is equal to 87. You have 4D square is equal to 36. This gives me D is equal to plus minus 3. Because in the question you are told that this is AP of the positive term. So that means I'll be taking D is equal to positive 3. So if d is equal to positive 3, let's fill in this equation. You have 2AD is equal to 51 minus 5D square. So 2AD is equal to 51 minus 5 into D square. Or this will be A is equal to 6A is equal to 51 minus 45, which is equal to 6. Or A will be equal to 1. I got the value of A as 1 and D as 3. Now, what you have to find out was A17 minus A7. A17 will be given by first term plus 16 into D minus, this is minus 7D into 2 plus 13D. So this is equal to A was 1 plus 18. 1 plus, wait, 16 threes are 16 threes are, this is 48. Okay. So this is plus 7 into 3, which is 21 into 2 plus 39. This is 49 plus 21 into 41. And on solving this, you will get 910 as the answer. So this is the answer to the question 910. Hope you're clear with this. 910. Okay, there is no option. Let's move to the next question then. Question number 28. Let A be given by this vector and B be this vector and C be a vector such that this is true. If the dot product of A and C is 130 and the dot product of B and C is equal to. Okay, let's start with what you have. We have A plus 2B cross C vector is equal to 3C cross A vector. So let's open this. This will be 2B vector and here will be 4A vector cross C vector will be equal to 0. So let's say C vector is equal to some lambda into 4A plus 2B vector. 4A, let's write down, this is 4I minus 12J 28K plus 2B 4I 2J 2K vector. So this is equal to, this will be, wait. I have done this as, fine. This is 8I 14J 30K. Also, you are given that the dot product of A and C is 130. A and C dot product is equal to 130. What is your A vector? It was I 1 minus 3 plus 7, right? So 1 minus 3 plus 7, the dot product with 8I minus 14J plus 30K is equal to 130. So this gives me, here was lambda, right? So this gives me 8 lambda plus 42 lambda. 210 lambda is equal to 130. So 260 lambda is equal to 130 or lambda is equal to 1 by 2. So you got your C. C vector was equal to 1 by 2 into 8I minus 14J plus 30K, or this is 4I minus 7J plus 15K. This is your C vector, and what I have to find out was the dot product of B and C, right? And let's write down B. B was 2 minus 1 and 1. So 2 minus 1 and 1. And C is this vector. So this gives me 8 plus 7 and 15, which is equal to 30. So this is the answer to the question 30. Hope you're clear with this. Let's move to the next question. Question number 29, the number of distinct real roots for this equation is. So this is your equation mod of x plus 2 minus 5x plus 1 minus 1 is equal to 0. So first of all, let's take the first case. When x is less than minus 2. In this case, when x is less than minus 2, so this will give me a positive x square plus 2x. Here will be, because this is less than minus 2, so this will be plus 5x plus 5 minus 1 is equal to 0. And it will be x square plus 7x plus 4 is equal to 0. So the two roots in this case will be, I want two such roots. See, x will be given by -7 plus minus b square minus 4ac upon 2a. This is -7 plus minus root of 4. This is 727. And this, see, this number, this is only 1 because when I'll be taking the positive value, this will not be root of 27. This is more than, like, it is 5 point something. So only one positive, like in this range, x is less than -2, only one root will lie because the another one will be greater than this number, -2. Because root of 27 is 5 point something, and -7 plus 5 point something, this will not be less than -2. Got it? So only one root is satisfying the range, which is x is less than -2. So you have one root over here. Second case, when x lies between -2 and -1. So in this case, it will be x lying between this. See, this was your number line. This is -2, this is -1 and 0. So when x is lying between this range, in this range, this will be given by mod of x into x plus 1. This will be minus x minus 2x, 5x, 5 minus 1 is equal to 0, or a minus, plus, and plus. So here will be, let's multiply both the sides with -1. This, so you will have the two roots as x minus 4 and x plus 1. So that means either x is equal to -1 or 4. So -1 and 4, because here -1 is not inclusive. So none is satisfying. None of the roots is in the given range. This range. None of the roots is there. So third case, when x lies between -1 and 0. So this will be minus x square, minus 2x, minus 5, minus 5, minus 1. This is equal to 0. See, this was a range. This was -2, -1, and 0. So now let's check within this range here. X into x minus 1, this will give you a negative value, and -2x, and all those things. This will be minus x squared minus this, or x square plus 7x plus 6 is equal to 0. The two roots will be x plus 6 and x plus 1 is equal to 0. Or the two roots will be, these are the two factors. So these are the two roots. So from here, this is satisfying this range because -1 was inclusive. One root is in the range. Fourth case, when x is positive number, that is greater than equal to 0. So in that case, you will have x squared 2x minus 5x minus 5 minus 1 is equal to 0, or x squared minus 3x minus 6 is equal to 0. Again, you will have x is equal to minus b plus minus b squared plus this 24 upon 2, which is 3 plus minus root of 33 upon 2. See, again, you will have, because positive number, this is 3 plus this, because 3 minus root of 33, this will give me a negative number. So from here, one root is in the range. So how many total? 1, 2, and 3. So how many roots you have total? 3 distinct real roots are there. Hope you got that. Let's move to the last question of this paper. Question number 30, suppose AB is the focal chord of the parabola y square is equal to 12x. If I compare it with the general equation 4ax, you will get the A as 3. So that means this is equal to 3. If the distance of the chord AB from the origin is D, see, distance of the chord from the origin is D. This is I have drawn already. You have to find out what is LD square. So L is the length of the focal chord. Focal chord length is given by, you have a formula for that, focal chord length is given by 4a into cosec square theta, cosecant square theta. So L is equal to 4 into 3 into cosecant square is equal to perpendicular upon hypotenuse, right? So what is the perpendicular over here? This is the hypotenuse. Let's write, first of all, this is like this. Now it will avoid any confusion. This is 12 into, this is hypotenuse square upon the perpendicular square. What is the hypotenuse? That is 3. So 12 into 3 square upon perpendicular is D. So this is your L. L is equal to 9 into 12 upon D square. Or you have LD square is equal to 108. So simple as that. You only needed to analyze the figure in this question. This is 108, last question of this paper. Hope you have got that, and students, with that we have completed all the papers, all the questions for this particular paper. And don't forget to visit our website www.examsnet.com. This site is a great place for you to practice all the entrance exam question papers along with the detailed PDF solutions. You must download our app also. The link is available in the description box. For a better preparation of your exam, so keep shining, keep rising high. That's all for this paper. Best of luck. Bye.